Alright, let's get the robot to move. What you need is two motors and a localization system. Alright, let's begin by creating a point. We're going to use point, and I'm going to name this one very creatively point. Now, best practice would actually be to create a smart point. But for the sake of this tutorial, let's create a normal one. So, let's just give it coordinates, and we're done with that. Now, how do we make our robot follow the point? We need to create an object called a follower and name it follower. Now, let's initialize it. Follower equals new path follower, like any other normal object. Let's pass it the post provider, and we're pretty much done with the initialization part. But there's a second constructor that takes in more data, that is PID coefficient, and it's used for fine-tuning the mechanism. Since we don't really want it fine-tuned right now and just need something to work, we're going to just leave it with the default PID controller. Now let's actually get our robot to move. First of all, we need to make our follower follow the point. So we just do follow point and pass in our point as a parameter. And then create a double array. So we're going to call it motor powers. And using that, we're going to use this method. This essentially calculates and extracts the ideal steering and driving power. To convert to that, we're going to use actually two more variables, and we're going to call it left powered and the other right power. Now, what we're going to do is pretty much standard practice for differential or tank drive, whatever you call it. And we're going to take 0, which is actually the driving power, and we're gonna add the steering power. And we're going to do the same for the right motor, but this time we're subtracting steering power from the driving power. Now, ideally you would want some normalization to take place in order for the driving base to ride smoothly, but we're just going to ignore it. Let's actually set the powers to our motor. So we're going to do it by setting the power to the variable. I mean, it's very simple. And we're pretty much done. Now, the moment you're going to hit play in your driver hub, the robot is going to start going to this specific position. But what does it do after it reaches the point? Well, oddly enough, it doesn't stop. In order for it to stop, it either needs to be perfectly in the point, or alternatively, we set a tolerance. So we do that by doing follower.set error tolerance. And let's just do a very generous 20, and we're pretty much covered. But what if we have more points? So let's just say we had 3 points. Yes, they are all in their respective positions. We create a sequence. We essentially tell the robot to follow one after the other in order. We carry on using our previous setup, but this time we add a point sequence, and we're going to name it sequence. Now this takes as the parameter the points, just the points. So you do point, point 2, point 3, etc. Now that we have initialized it, the only difference is instead of following the point, just follow the sequence. And that's about it. So this is the end of another tutorial. Thank you very much for watching, and καλή συνέχεια.